This meeting is being recorded.
Guest present here. I will talk about a few words about the project. First Responder Advanced Technologies for Safe and Efficient Emergency Response. That is the acronym FASTER, because we think that our emergency operation should be faster, because it is life of some victims in danger. What is the project? The project is one of the enterprise within the European Union. It is within Horizon 2020, and we, with the consortium partners and the partners with our support, are trying to find solutions for any kind of emergency services, law enforcement, whatever security and safety services acting at the crime scene, disaster scene, natural or technical source, where the people are in danger and where we need to serve to help the people to getting them out of the real trouble. As you can see, we have a lot of partners from the European countries, but also we have the partner from Japan. And that very broad consortium gives us a lot of different points of view on the problem of security, but not only security and safety of victims, but especially of the rescuers. First responders, whoever it is, at the crime or disaster or crisis situation scene, is someone who is giving her or his own safety to serve and to help somebody else in the dangerous situation. We have partners from Portugal, from Spain, France, from the Netherlands, Belgium, Italy, of course from Poland, from Greece, from Finland. I must admit that, but I would like to admit that cooperation within the consortium is really, really good. Exchange of information is really, really the thing which is the most important for us. We can talk, we can ask as a law enforcement participant with all technical partners, and they are very open to listen to our needs, what we would like to say and what we would like to have within the technologies and devices they are preparing for us. And the same way we are open for their remarks, what is possible and how it is possible and how it can benefit to the actions, to the operation at the scene in a crisis situation. The concept of the project was very clear. We need to help, we need to support first responders in their actions. We need to give them something which make their work easier and more efficient in life savings, and also can in somehow keep eye on their actions at the scene. As you will see in the next slides, we prepared some parts of technologies and tools, and definitely what are the most, let's say, popular needs of the law enforcement at the scene. That's the connectivity. We need the connectivity So therefore, support for reliable and resilient communication is very important. We need equipment. We need devices useful and easy to operate and light, just to have them not for ourselves, not for rescuers' needs, but to serve more for the victims. Therefore, we need as well vehicles, therefore we need the drones and the other equipment. But personally, for rescuers, we found some solutions which are mobile and which are wearable devices. The heart of the system is COP, what is Common Operational Picture. It's a kind of software which is, for now, a kind of map with some solutions and functions where we can see all the rescuers, equipment, all the forces present at the scene. And the operator of that COP in a portable command center can support or can give a clear image of the situation of the scene for the leader of the operation, for the commanders. It's better.
Okay. Thank you a lot. So sorry, again, it's my fault to not inform you about this. For writing.
I think it's not okay with presentation, but maybe that's better. The part of the project is also based on the augmented reality and some of the tools used for that. For example, HoloLens, and we would like to provide the rescuers, especially acting at the scene of the terrorist attack, with a kind of walls through watching. So, for example, if we have some plans or some pictures from the drones from inside of the building, we can provide the rescuer or operator of a counter-terrorist team what is or what maybe is going on within that building, on the roof, or the rooms, when we cannot see and cannot get directly to that building. The next part are mobile technologies. So, for example, for rescuer, we think about a kind of mobile phones or that kind of devices, but also for some sensors within the wares, as well internal as external, to collect data, biometric data, or environmental sensors to collect environmental data. What is going on with a specific person, specific rescuer? It can collect and show on COP the status of a police officer or firefighter, if all the biometric factors are okay, and also from the code, because that environmental sensors are placed over the external part of the wear. If we use it, they can collect information about the state of the air, about the pollution, about the CO2 level, or whatever it could be quite useful for the others if the environment is enough good to open for the other law enforcement or rescuers to act at the scene. Today, colleagues from Greece, they show also part of the project about the gesture and body control of the drones. It is based on recognition on some movement and gesture of the person, and also with using the smart watches. And those devices, as you probably know, can easily recognize some move of the person, of the body, and sometimes it's very useful. Okay. Interaction with K9, a very good idea. So, for example, having someone who is missing in a wilderness, in a broad and difficult area, we can now think about living and giving the opportunity to free acting of a sniffing dog who is searching for missing person, not operating with the handler. So it means that we can throw out the lash of the dog, and the dog can get faster and directly to the person, for example, in the woods or in somewhere, as it was checked in Madrid, to operate in a small spaces when the buildings after earthquake is collapsed, and can get directly to the victim. We can, on the COP screen, watch where the dog is and where it is operating, and also with special collar, the position of the dog and the movement can be automatically recognized, and when the dog is finding the victim, for example, sitting and staying in one place can be recognizable as a sign of a victim found. Also, we would like to provide that collar with communication for the dog and for the found victim. It means that we will have the speaker and the mic within that collar, so the handler can give the orders to the dog, or if the victim can communicate verbally, can talk to the microphone, and we will hear that from the distance, and we can provide with some instructions how to help themselves before the rescuer get to the victim, how to prepare for how to secure better the wounds or whatever kind of the danger is for the victim. Also, the dog can provide some small things, maybe a small portion of eat, something to eat, just some sweet if the victim is exhausted and needs something to drink or something to eat. Vehicles and drones, we think about robotics platforms, the rovers. The rovers can be steered by someone, but also as autonomous vehicles, and heavy drones, not only for mapping, for being, let's call it the eye of the leader, but also to provide very detailed image of the scene, but for transport operations. So the bigger drones can provide some rescuers who are far from the source of the equipment with some small parts, some small parts of equipment, rescuer and especially paramedic, they can need some more things to secure the wounded people. And also, for example, if we do not have enough light in some specific place, the drone can provide the lights from it to light up the scene and to make rescuer more easy to perform their duties. As I mentioned, the connectivity is the most important and basic need of the nowadays crisis management situation operations. So we need our own net at the scene, and the future is 5G, and between some of those parts of the faster system, especially between the things, we need a really efficient Internet of Things connections. We need very good connections to get, for example, from the drone the image and have it faster. And also we need that in the situation when the internet connection, the mobile connection is not present. Because, for example, if there is a terrorist attack, usually the mobile phones and the internet connections are turned off. So we think about having transponders and amplifiers of the signal at the scene, preparing in some specific places to provide all the rescuers and all the equipment exchange of data. Therefore, it is a communication equipment rescue, but about that, one of the colleagues from Greece, Mr. Kogias, will say later on. Okay. I would like to the participants of the telco to turn off the microphones, okay? Maybe a part of the future of the project, but we also think about that, is to having the information from different kind of sensors which are present in our building, especially building for public purposes, from shopping malls, from railway station, public authority buildings, and not only the sensors about within the anti-fire system, but also the cameras, also the sensors. If we can see if there are some doors open or unblocked, if it is internal system of opening and blocking the doors, and many more. If we can get that information from some specific buildings, we can performing operations there. We can have more information and more awareness of the situation within the buildings or objects. Use cases. First, we thought about, in general, crisis management. So technical disasters, when the constructions or industrial objects and the others can collapse, can be destroyed, and for example, in some factories, people can be affected or can be wounded or unfortunately dead. We need that system to operate, because in that situation different threats are present, especially within industrial objects, companies, and when in the production process there are used a lot of chemicals and different substances can affect people, can be a poison and danger for someone. We need to think how to recognize the presence of those substances or poisons within the water, within the air, especially before someone of the rescuers, first responders are at the scene. Secondly, we have natural disasters, so flood, earthquakes or hurricanes. There are plenty of that kind of situations nowadays in the last few years. So operating at that massive scale scene, we need a lot of different law enforcement or security services, but also technical services, emergency services. So we need to think about cooperation, the connectivity between them, and the faster with COP system is giving that opportunity, and therefore we are working on it. And very important situation, terrorist attack or hostage situation, where the people's life in direct danger, specific situation, that also in some buildings and objects we do need more coordination and more information and exchange of information and the awareness of the situation for providing better and safe service for the victims. So that's all shortly, briefly from my side. Thank you very much. And I would like to join Nicola, if you are present.
Hello everyone, it's Nicola from engineering. Can you hear me? Hello everyone.
Hello, Nicola, how are you?
Can you hear me well?
Yes.
We're having some interruptions. I don't know. Okay. I guess I can start sharing my screen with the COP system. Do you see my screen?
Yes, we can see.
Okay, I'm gonna start by navigating through the menu. Here we have many different tools, which we are visualizing.
Scout, like I said,
Słyszę Cię bez problemu, tylko wiesz co, ja równocześnie jestem na takim spotkaniu.
Can people not talking close the mic, please?
Nie, no jakiś eko się niesie, nie wiem. No i to tak jakby ktoś zapowiadał pociąg.
Hello.
Nie. To może, nie, ona jest u każdego jest tak samo. To może jak się ją kliknęło, to tak. U mnie też jest u góry Olimpia Bogdalska, to gdzieś
Can everyone hear me? There's an echo. I don't know why.
People close the mic.
A second. Okay, I guess I can start now. So is everything well? Can everyone hear me good? I'm gonna start by navigating through the menu and showing you different tools that we are visualizing on the COP system. First of all, I would like to start with the mission management tool. This tool, our partners, technical partners, are generating and sending us data, which we are processing and visualizing on the COP system. Okay, so as you can see, we have the list of missions that are created. There is one mission created for Polish pilot. So, for example, let's start by clicking on location of the mission. If we click on location, it should take us to the exact location of the mission, which it does. And here, if you click on edit mission, you can see all the details of the mission, the status of the mission, that it's been created, when the mission has started, and when the mission has ended, who created the mission, organization, and the description of the mission. Now, this is just some test missions that are created on the COP. If you want to create a new mission, then you go to this tab, Create Mission. For example, let's create a new mission on a different location, let's say. And let's call it Test Mission 2. We can also add the description of the mission. I'm gonna just select some time frame of the mission. Okay. Polish pilot. This is the situation that we are using for this mission. The organization that is creating the mission and the team. And here we have a map where we create the mission. So let's create a new mission in Warsaw, for example. You can create the mission by selecting the polygon tool. And when you click on it, you click once, second time, third time, and for example, if you click on fourth time, it has to be a double click. And then you can submit the mission. And it's just so, and if everything was good, it should show the message that mission is created successfully. And now, if we go to Inspect Missions, we see here that a new mission has been created. Let's go to the location of that mission. And it takes you to the exact location of the mission. And of course, showing all the details that are necessary. Of course, there is a filter that you can search by for this list. Like you can filter out the status of the mission, and you can filter out start and end date. And when you click on search, then it should show the missions with all the filters. Okay, let's move on to the next tool. Let's zoom out a bit. Next tool is reports. We are also seeing a list of all the reports that are generated by the users that are using the chatbots, and our technical partners are generating those reports. And of course, we are also visualizing this. For example, if a report has been created with a picture, then we can see the details of the report. And we can see the picture that the user has been attached with the report. And of course, you can see some more details of the report, who created the report, and the source. This is, for example, augmented reality source of the report. let's go to the location of this report, for example. And it takes you to the location of this report, and I'm not sure which one is it of. So it's probably one of these. I think it's this one. Yes. So as you can see, you can also click on the report. You can click on the point on the map. And if you click on the point on the map, then the picture is also shown. Okay. Can everyone still hear me? Good.
Yes, we can hear
Okay,
you.
great. Just wanted to make sure. Also, you can filter out the list, just like in Mission Management Tool, by selecting the start and end date status of the report. You can also search by hazard type. For example, if we have now we have, I think, one avalanche, yes, and if we filter out and start the search with avalanche hazards, it should only show, and it is showing only the results with avalanche status. And of course, with all the necessary pictures that were shared. Also, there's a possibility to share a video, but we don't have any examples here. But there is a possibility to share the video with the report, just like pictures, so you can see the video from the location. Another tool is persons. We can see the list of all the persons that are using the chatbot, and the only thing that we are showing here is the status of the person. This is, for example, off, and the location of the user that is using the tool provided by our technical partners. And of course, there's search options and filtering options. Next tool is communication. This is also just visualizing chatbot location, for example, where the message is sent from. So for example, if you click on the location here, then you can see the persons that are using the chatbot tool from the technical partners. We can also visualize where the message is sent from and when it's ending. Okay. So the next tool is social media analysis. Let's just wait for it to load. Here we are showing the list of all the tweets that are shared with us, that are shared with the COP. We are generating the tweets for hazards. For example, if there is a flood, someone shares a tweet with this field flood, then it is sent to us, which we are visualizing. And if, for example, you want to see the location of the tweet, if the location has been sent with the tweet, of course, for example, this one has a location, you can click on this target icon, and then you can see where the message has been sent from. I mean, the tweet. Of course, if there is a picture with the tweet, then picture is also shown. We also have the possibility to share the tweet with the personal Twitter account. So if you want to share the tweet from the COP to your Twitter account, there's also possibility to do that. Here on this tab, on this panel right here, we are visualizing some other information. For example, how many pandemic events has been generated, how many floods, how many wildfire. If, for example, you want to filter out the information, there's also a possibility to do that here. For example, let's only filter out the information by hazard type wildfire. And let's start the search. So, as you can see on the list on the right, it filters out only the tweets that are related to the wildfire. And we are showing the event name by this tag here of the tweet. And also all this information, as you can see on the map, all these points are clustered, meaning if there are many points and if you zoom out on the map, then that information is clustered here via this number. Okay, so for example, let's search the information type by affected people. Let's start the search. Then also you can see here how many people are affected by a particular hazard type. For example, here, 584. And also this information is filtered out on the map and is filtered out here on this list. Next tool is closely related to this one. It's called Events. It's fairly similar to this one, but it's showing some different information, also different kind of map. For example, here we are only showing the events. For example, if there is a fire in Donbass, we can click on the location just like in social media analysis, and it shows you where this event is generated. If you click on impact estimation, then you can see currently, I think, okay, but if you click on infrastructures, you can see how many infrastructures are affected by this event. There are many different infrastructures, and you can see also the population that has been affected, how many are evacuated, how many are hospitalized, how many are infected, etc. And just like social media analysis tool, you can filter out this list and you can filter out the information on the map. Storm, for example, and if you start search, then this list is updated with hazard type storm, and map also is updated only showing storm. And just like I showed you on social media analysis, there is a possibility to also show the information here based on the information type that you selected. Okay, so let's go back to the map. Another tool that we are able to visualize is 2D mapping. Here we can see all the drones that have been used to create a 2D mapping. I think we have one example on the map that I can show you today. Just a second. There isn't any, but we also have the possibility to show the 2D map that drone has been generated and sent to the COP. This tool I cannot show you today because in order to show it, we need to collaborate closely with our technical partners. You know, they need to operate their tools in order for us to visualize the AI scene analysis. Other tool that we are able to visualize is points of interest. For example, if you click on this icon here, and if you click on show, this is currently not working. I'm not sure why. Let's refresh the page. Okay, so here, let's go to the Polish site. We have points of interest, and you can see all the details related to this point of interest. This was also generated by our technical partners, and you have on the COP, you also have the possibility from the COP to create a new POI. I'm going to show you just in a moment, but let's this is not. I'm trying to click on the fire extinguisher that is located in the Polish pilot. But not sure which one exactly from the list. Maybe this one. No. Okay. I'm going to show you now the possibility of creating new POIs on the map. For example, if you want to create a new POI, then you have to do a right click on your mouse. You can select POI type, for example, risk. You can select the subtype, what kind of risk, biological. Test. And here, if it's biological, it shows the icon risk biological. Okay, so the next tool is weather info. There's a list of all the weather stations that are present on the map, and if you click on the location of, for example, this one is located in Spain. You can click on the icon showing you some information related to the weather station. But if you click here on the list, on the details, then it shows you some more information that is generated from the weather station. And if the weather station is provided a link, you can also click on the link, taking you to the local weather station page. Here are many different information that the weather station is sending and that we are visualizing. Okay, so I'm going to show you now the possibility of creating, let's create 2D mapping, but I'm not going to show the results because our partners need to operate this tool to be generated. For example, if you use the polygon tool from the map, and if you want to create a mapping request, then you, just like when you create a mission, double click, and if you want to create a mapping request, here you have the possibility to select which type of mapping. You have 2D mapping and 3D mapping. So for example, let's say 2D mapping and overlap, set the altitude, and then you can test the mission. But in order to show you the real picture of the 2D map, like I said, it has to be operated by our technical partners. And I thought that we were going to have some example of the 2D map, and I think we do. Oh, here it is. Now it's shown. Okay, so now if the drones are done operating on the field, and if drones send us all the generated images, we are able to visualize the detailed image of the 2D mapping, just like you can see. So it's more easier to spot, for example, a victim on the field here with this more detailed image. Just like 2D mapping, we can use the polygon tool, which we can create some situation related to the particular event. For example, let's create a situation here. So if we name the area test area, here you can select the severity by medium, high, and low, description test, and you can, for example, say it's an environmental hazard type. And when you click save, refresh the page, on the left you can see this menu here, and if you want to click on the area, it takes you to the location, and if you click on show areas, you can see the area that has been just created. And you can also click on the area, showing you some information here. This is all just some dummy data that I just created, and also there's a possibility to edit and delete the area. And there's also a possibility, let's just zoom out. There's also a possibility to filter up the whole map by entity filter. For example, if you want to only see persons on the map, there's a possibility to do that. Let's just select persons and let's click submit. And now it's showing you only persons on the map. If you want to just see the reports on the map, now it's showing you only reports. Also, of course, this is when you zoom out, the information is clustered into a number that is related to this area. And if you want to reset the information, just click on reset, submit, and it reloads all the information on the map. There are many different tools that I'm not going to be able to show you. For example, biometrics data, video streaming with drones, K9, the smart textiles, which we are able to visualize here on the map, but not today, since technical partners are needed to operate their tools, and of course to send us the related data, and which we can process and visualize here. That's about it regarding the COP system. Does anyone have any questions maybe related to this? If not, then I guess that we can proceed. Hello.
Hello, Nicola.
Hello.
I don't know if there are questions from my side or not, for sure. Thomas?
I cannot hear Thomas.
George, can you hear Thomas?
I can hear.
Okay.
Okay.
If there are not any questions, I will stop presenting, and we can continue with session.
Okay.
Okay.
Thank you very much.
You're welcome. Thank you.
So, we will present you how to manage a drone by gestures. This is a tracking module, and also we can track a drone and can manage it by hand. So we can make a lot of stuff with the HoloLens device and okay, so I can manage the drone with my hand, and I can get feedback what the drone can see. There are two modules, the egocentric view and the FPV mode. So in the egocentric view, I can see the video in the view of the drone. So if the drone is in somewhere, I can see what the drone can see in the scene. So it's not only one view; it's in the space. So it's more intuitive for the user what the drone see and where, of course. So if the drone is behind of a wall, the user can see inside of the walls and can provide the spatial information. Also, in the FPV mode, it's more intuitive for the user. They can see in the side of the drone. I will show you how to manage in a demonstration in a few minutes. which you can see what the user of the HoloLens can see and how to manage. So in 1-2 minutes, I will show you the demonstration.
Drukowanymi.
Yeah. Google Chrome. Excuse me.
Teraz mikrofon musi wziąć. W sali mówię. No to się skupić w sali, czy skupić przed komputerem. Jak w sali to mikrofon musi trzeba wyciszyć. No. Czy wyłączyć, tak? Znaczy jak w sali, to z tego szala.
Ludzie słyszeli?
Tak.
Nie słyszeli ludzie.
Nie słyszeli to. Dobra. Gdzie powinien być słyszał? On będzie na sali. Czyli też sobie ciszy, bo pójdzie. A tutaj ja się przyspękam. Połączony, bo musi być, czy też, czy jak to zrobię, to się już nie tak. No to dobra, tu jest.
We are inside on the application in the HoloLens. We're waiting to have a configuration. As you can see, here I have a panel, so it's my main panel. From here I can I have 6 buttons: play video, stop video. I can reset the camera because I can control the gimbal of the camera. Also, I can enable and disable the extended vision tracking and the camera mode because any drone has a different modes of the drone, like a thermal camera, mixed camera, or RGB camera. The configuration is finished, so I can have a calibration between the HoloLens and the drone. I just look on the QR code, and the drone has So after the calibration, as you can see, the drone is exactly in the same place on the space with a virtual drone. After that, I can enable gesture navigation mode. So now I can fly the drone. I can take off the drone with my gestures. So as you can see, the operation is started. Has been a little bit lag. So after that, I can move up. Eh? So I enable the gesture navigation mode again. So I have my hand. If I want to move more upside, just like that one, and stop it. As you can see, the virtual drone moving as well, the actual drone. I can disable now gesture navigation. I press play button. So, excuse me. So, yeah. We have also one mode which called periscope mode. So I will take off again just to see this module. Okay, so I enable periscope mode, and the drone now sees what in the direction with my head. So if I change that one, the drone also continues the moving and look in the same direction of my head. So if the drone stands on the same direction, and after that, if I move and rotate my head, the drone just follow me. Of course, we can play with a video, so we can see in the direction the video of the drone. But for now, we have a problem with a technical problem. For that reason, we don't have the video feeding. But in the purple presentation, you can see in the good operation, you can see the video. So for now, I disable it again, and I disable periscope mode. I enable also again the gesture navigation, and I can take it down. The last tool I want to show you is the camera control. So I can control with my left hand the gimbal. So if I move it up and down the gimbal, I can control gimbal of the drone in multiple directions. Of course, in the main panel, I can see drone information like drone distance from me, the heading of the UAV and mine heading. Also, the altitude is 10 centimeters only. This is the tool. Yeah, I can do it. That. Yeah, sure. Don't worry, it's very safe. Just landing and take off. It's not moving. Yeah, it's our solution. Both of Android and HoloLens. Of course, we are using the tools like gesture founding, but we can use these tools like the HoloLens, and I can handle this test.
Presentation and that show definitely that technology is the future. First responder sometimes has to have the free hands to do something, to operate with something, and so the opportunity to control the drones with the gestures is something for the future and will be very good. So, can we connect to Fabio? Fabio, can you hear us?
Yes, yes, good morning.
Good morning. We have a short delay, but we would like you to...
So if you are ready, we can start with the asking our advisors to give us their opinion about what we are doing in this project. I will close my camera. I will share the the presentation. Can you see the presentation? Can you confirm you are?
No, Fabio, I don't see the presentation.
Okay.
Okay, it's here.
You can see the presentation now?
Yes.
Okay, great. I will introduce. Thanks a lot for the two advisors we have participating to to this meeting. I will pass the floor to Arthur Costa to introduce himself and to tell us something about what he saw during the project life. Please, Arthur.
Okay, Fabio, can I show my presentation, or do you put it here?
It should be there. Can you see that?
Okay. This is not right because there are two slides, one over the other. Okay, this refreshment of the video is slow.
Well,
okay.
The slide is the introduction of yourself.
Yes. Good morning, Fabio. Good morning to all of this meeting. Fabio asked us for a few words, and in first I couldn't do that because of the presentation of a master thesis in which I was part of the evaluation jury. But the agenda has changed, and I'm here now. I must add that English is not my specialty, for which I apologize. I want to thank you for the great opportunity and honor to participate in this meeting and in FASTER project. Although very distant and with a poor personal involvement. FASTER is a great and promising project with impressive results, and it should not end here. It must go on because it is necessary to better work of all stakeholders, amplifying capacities with higher levels of safety for first responders. FASTER is a very, very important project for all these agents. My name is Arthur Costa. I'm talking from Portugal. I entered FASTER Advisor Board on the end of 2019 November, and before on November 8th, from November, I organized at Universidade Lusófona do Porto, in partnership with the municipality of Grândola, from Portugal also, a public session for the presentation and dissemination of FASTER. I think it was the first session about FASTER in Portugal. Fabio, can you go to the first slide? Can you change to the first slide, please?
Okay.
Okay. Let's the video refresh. I don't know if you are seeing it. I'm not. Oh, now the back one, please. First one.
Can you see now?
Wait a minute, please. The bandwidth is okay. It is here. A brief presentation of myself. I have a PhD in electrical and computer engineering, and my interests are around education and science dissemination, civil protection only, especially in civil protection and safety, and also in electrical machines and power systems. I'm invited full professor at Lusófona University. I'm also assistant professor at the Faculty of Engineering of the University of and in Lusófona University, I'm coordinator of the first cycle degree of in civil protection engineering that I founded like a master degree in civil protection, both at Lusófona University, and I suppose now they are unique in Portuguese universities, the first ones, and now still the unique in this area. Please, the next slide, please.
Let's wait the video.
Okay, the video. Okay, not this one, but the other. As I said, I entered.
Is that okay?
Let me see, please. Not this one. The back one. No. Back, please. The video goes very slow.
Arthur, can you hear now?
I'm not seeing now. Yes. It's my second slide. Yes, this one. Oh.
Is it okay?
Just a minute, please. Fabio, it's possible to me to...
Yes, share your presentation.
Yes? Okay, thank you very much. I will try. Are you seeing?
Great, yes.
Yes? Okay. As I said, I entered the Fighter-Board on the end of 2019, in November, and a few days after, I organized at Lusófona University, in a partnership with the municipality of Grândola, a public session for the presentation and dissemination of FASTA. It was very, very in the beginning. I think it was the first public session with these objectives, with these goals in Portugal. I was particularly identified with some ideas and objectives that are well expressed in the project's name. The name is a good name. The hard words was safe and efficiency, emergency, and fast responders safety. At that date, these objectives, these goals, was to me very, very, very sound, very important. I only followed the project, not in person, but through documentation and videos distributed. Okay. At the beginning, my first impressions are about the impressive team and the greatness of the project consortium in a very promising alliance between research, users, and industry from different countries and geographies, as we see and we know very, very, very well. Another very strong impression was the vision of the goals of this project. 3 years passed, and now I can resume my current appreciation, saying that talking about the extensive tests and demonstrations in different contexts and uses about pilot exercises highlights the usefulness and the great potential of the technologies and solutions developed. Another point, the wide dissemination already carried out with the in different countries, via different stakeholders, okay, and now there are very, very, very strong results attained. In these few words, Fabio asked also for some suggestions for the project for future. Because of the goals achieved that are very, very impressive, because the innovative technologies that can save lives, really, technologies that expand action of agents in security and rescue operations with increased levels of personal safety. So I think, and what I can suggest to the future is dissemination and training. Also certification, industrialization, and more. Dissemination is very, very important and can be done while training simultaneously persons. Okay. I think this dissemination training will be very important to be done with near firefighters, civil protection, and security agents, all entities that are particularly interested in these results. Okay. Certification. Certification. We and certification should be future-based. Okay, I suppose that certification was not yet done. Okay, the next step goes to industrialization of the most robust solutions. That must be the last step, yes, as I said. But because this project has a very, very impressive lot of people involved, why not to continue this project with that same team and all the stakeholders it has now. These are my propose for the future, and with these few words and in few minutes, I must congratulate all the team. Thank you very much. And here my email if you need it to contact in future. Okay, Fabio, I'm sorry for my bad English. I hope you have understand the main ideas. Okay, and thank you very much to you also.
Okay, Arthur, thank you very much. We understood you very well, so no problem with the English at all. It was absolutely a pleasure to have you in this advisory board. And what you are suggesting are exactly some items that are reported in our exploitation plan, because for sure the capacity for first responder is a key point in order to introduce new technologies. But also we know that for a technology to be used in emergency field, they need to be certified, and a deep process of industrialization will be in place. To be very clear, this project was not intended to release industrial product, although we have some of them that are really very close to their deployment, because, for instance, we have in Italy the Piedmont region who is going to adopt officially one of the outcome of the project. So thanks again for being part of this this crazy group of people working around emergency. And now I will pass the floor to Sandro Bologna for his point of view. Sandro, I'm trying to share the presentation. I hope we will not have the same issue I had with Arthur. Tell me if the presentation is, you can see the presentation. Hello, Sandro? Can you see the presentation? Sandro, probably you are muted. No, it's not working.
Fabio, can we enlarge the slide of the presentation of Mr. Sandro?
Yeah.
You are seeing the presentation.
I can see the presentation, but I can't now. Can you hear me?
Yes.
Okay. Good morning, everybody.
We cannot see you because you are in the dark.
Yeah, okay, but I got the wrong link, so I changed it from my desk PC to a laptop, and I am in the dark. So I don't think it is important to see me. What is important is to hear me. Can you hear me?
Yes, absolutely.
Yeah, okay. Good morning, everybody. My name is Sandro Bologna. I'm not a first responder. I think that is important to say at the very beginning that I'm not a first responder, but I am a scientist, and I spent my career and more than 40 years at the Italian Agency for New Technology, Energy and Sustainable Economic Development. So I was really impressed by the technology that has been developed inside the project. And well, I have attended online some of the demonstrations, and so very impressive the improvement in the technology. But because I was asked to make comments and suggestions for the future, can you go to the next slide, please?
Okay, give the system the time to refresh.
Yeah, okay.
Is not...
No, I can't see the next slide, but I can talk.
It should arrive.
Yeah, now I can see. I think that suggestions and comments were already included in the questionnaire that has been prepared by Fabio. And you know, I have experience in projects like FOSTER project, and my position is that the real problem is not only to develop a new technology, but to test the technology in a real environment and to see how difficult it is to introduce new technology in the process, in the organization. When you are suggesting a new technology, normally you need a training of the people. Normally you use a reorganization of the entire project, entire process. Sorry. Normally also technology is costly, and the personnel has to be prepared, and all the how to use the technology and so on. So I would suggest to continue with the project, maybe with another proposal. This was also a suggestion from the previous board member. But not to concentrate in the upgrading of technology, but considering how the technology will impact the process in the organization of first responders. How difficult would it be to use the technology? How much training it would require? So that is my suggestions. and I would like to end with this way of saying, I'm coming from a research world, and I've learned from the very beginning that a tool is only a tool. So it is not enough to produce new tools. It is not enough to suggest new tools. It is important to see how the new tools can be integrated in the process, how difficult it is, how costly they are. And I think it is an error try to follow the upgrading of a technology, because always there will be somebody else in the world that is producing a new technology, and there may be more performance technology. So my suggestion is to concentrate on the process, on how to use a technology. That are my suggestions, Fabio.
Okay, Sandro. Thank you very much for your suggestion. I fully agree with you that the processes are the key point. So technology are, let's say, are useful facilities, but we need really to understand how the process should run. And simply to add a comment related to all these technology and the processes, I think all these technology, they have a common glue. The common glue is the communication. And when I talk about communication, I'm not talking about networking in terms of Wi-Fi or 4G, 5G. For sure, the network infrastructure is a key point, and probably also not the most reliable one now. But the communication, so how to communicate between different level of first responders, and how to, let's say, share the management of technologies in place. This is another point that, as you said, should be addressed, if possible, in a further proposal that, for instance, we can plan to submit in November 2022 at the UNESCO. This could be really an opportunity. Thanks a lot, Sandro and Arthur, to be part of our team. There will be a pilot in Spain. I want to say that if it will be in April, I hope the situation will be more, let's say, quiet at that time. In the case, you are invited to join if you want.
Oh, thank you very much. Spain is.
Thank you very much.
Spain is for sure in May is a better climate than Poland in February or in the beginning of March. I would consider to be there.
It is in April, and it will be in Madrid.
Okay, but better climb, and I will consider to be there. Please send me the invitation.
Okay. So thanks a lot. I think that's all for the advisory position. I leave the floor to Thomas and George to continue the meeting.
Bye-bye.
Bye.
Thank you, Fabio, and thank you, Mr. Costa and Mr. Bologna for those words are very important for us, not only for whole the project but also for the participants. I would like to break for a short coffee, 10 minutes, and after that, Mr. Kogias from Greece will present about animal wearables, and then smart textile framework, and resilient communication equipment rescue. So 10 minutes break. Thank you.
Nie no, ja nie chcę, Boże. Ja nie chcę. Nie słyszę, więc nie wiem, o co chodzi.
Dzień dobry Pani Agnieszko. Czy Pani mnie słyszy? Hello, everyone. Okay, I would like to ask Mr. Dimitris Kogias from Univa to present the next about animal wearables. Dimitris, are you with us?
Hello, everybody. Can you hear me?
Okay. Can you hear us? We
Let me share
cannot hear
my
you.
screen first. Okay, can you see my screen?
Yes, we can.
Okay, excellent. It's okay if I start?
Yes,
Okay.
please proceed.
Thank you. Okay. Hello, everybody. My name is Dimitris Kogias. I am from the University of West Attica, and we are part of the FASTER project. First of all, let me tell you that I'm very glad to be here with you, even though remotely. Hopefully next time I will be able to join you there. Now, as for our role in FASTER, we are developing a lot of some tools that can be used by the first responder, and I am here to talk to you about three of them: about the animal wearable, about rescue, and about the smart textiles framework. I will start with the animal wearable. Please let me know. You do have a piece of the wearable there. Is that correct? I don't know if it is available in the room there for now, but I think that you do have access to a wearable, animal wearable device. In any case, let me start by, first of all, describe you what this tool is about. It is a novel wearable device, and the thought behind it is to be able to further enhance the assistance that comes from trained animal units. And in FASTER, we have been using canines as the animals who are about to wear the wearable. And the whole idea has been engineered and designed in order to provide, this is what is expected from this tool according to the description of action. The tool should be able to provide real-time animal status recognition, activity recognition, and translation of animals' behavior into a predefined message that could be addressed to a person in need. That, for example, one thing that we want to show is the fact that when if the animal searches for a victim or a missing person, when the animal manages to locate it, then the animal should sit down and bark, and this could signal to us the fact that a person has been found, and we can locate his whereabouts. Now, in addition to what was described in the description of action, we have been in close contact with the first responders in the project, especially those that handle canine units and train them. And they asked for us that there are also some important factors that should be taken under consideration about the tool, and these factors include the shape and dimensions, and of course the tool should be designed in such a way to ensure that the animal is safe by wearing it in the field of action. Okay, so in summary, the animal wearable, what it can do is that
Tutaj zatrzymujecie, czy wypełniacie niebieską kartę, tak? Na szybką
sali i zrobimy scenę.
I'm sorry. Is there? Okay. If someone wants to ask something, please do. Just go on, and if there is a question, please. Now, the wearable can be used to geolocate the animal. We have also, as you can see, this information. I will explain where this information can be displayed on. And also, the wearable can be used for detection of barking from the animal, and along with activity recognition. And by activity recognition, in FASTER, we mean whether the animal is moving, searching for someone, or whether the animal is sits down and waits. Now, we are trying to use this combination of information in order to be able to understand when a victim has been located. I should point out that since FASTER is a 3 years program, by addressing with first responders, we came under the agreement that it would be difficult if the activity recognition that was going to take place involved moves outside of the animal's training, at least for the animals that are used in the project. Therefore, the specific combination of barking and movement have been selected because they were already part of the animal's training. Therefore, they could be used by the animal, and we could train the algorithms to understand whether something like that takes place. And this is what we have done, and I will show you later on. Now, I told you that we have been collecting this information, and this information should be displayed somewhere. Where in FASTER, for the animal wearable, there are 2 places where this information can be displayed. The first one is the pickup or the COP. I think that you were able to see a demonstration of the COP earlier on here in this stakeholder meeting. And there you can see also we can see also the location and the results from the bark detection and activity recognition of the wearable. In addition to this, as you can understand, COP is a tool that could be located in an administrative panel, and a pickup also can be located in the tablet near to the location of the animal. On top of this, in addition to this, we have been developing a smartphone application that could be installed on the dog's handler smartphone, which would be much simpler and would just show the location of the animal along with some gestures about barking and activity recognition results there. I have a demo later on that I can display to you in order to understand how this smartphone application can be used combined with the information coming to the cohort pickup. Now, some talk about the evolution of this tool. Well, in the description of action, when we were writing the proposal, in our head was the fact that this is something that should be like like a collar for the animal, and this is what we have been describing on. But very early on the project, by talking with the first responder, it came to us that this is a solution that may have some difficulties in applying to scenarios, for example, where the animal should go under the debris to search for possible victims. So we started with thinking about how to design something for a collar in order to comply with the description of action requirements, along with the safety and user requirements described by the first responders. And first, we started to think of something with using like one box with where all the electronics were placed. But after discussions, we understood that this weight should be evenly spread along the collar. Therefore, we started also creating prototypes having 2 or 3 boxes, and this was our first version, the one that contained the 3 boxes, where we have split the possible features and electronics of the tool to these 3 enclosures. And also we have been trying to find a solution where this collar could be easily tear out when the animal gets under the debris and gets tangled with. Therefore, we have been, in this version, the one in the middle, we have been preparing a prototype that used magnets in order for the animal to be easily freed when it gets tangled with under the debris and it forces its way out. After testing it in the first series of pilots, we understood that this is something that could be enhanced. We could work something better, and then we came up with another version that we got away from the collar, and we get closer to a harness solution. This harness had the electronics in the front of the animal, as you can see here. And we started to test it with the first responders, and also we have been trying to monitor academic publications regarding our main focus, which was the preparation of the algorithms in order to be able to deliver the activity recognition, the bark detection process. And so we have seen that in the literature there were works that pointed out that it would be better to locate the electronics on the back of the animals of the animal. Therefore, we have come up with the last version. This was the 3rd version, in fact, of the design of the animal wearable, where the electronics were placed on the back, as you can see here. This was the version that was used for the data collection process. It was a long process because we needed to collect data, to have a video, and tag them. For that, these data were needed because we had to train the algorithm and be able to test its performance. I will show you more about this later on. This is the final version of the final design of the animal wearable. It is completely modular. We have a camera that comes off if it's not needed. This is the pouch for the electronics. This is a pouch for an extra device. In fact, it was your first responder that came up to us and proposed that we could have a small pocket, let's say, where the animal can carry a smartphone to the victim in case it's able to communicate with. And even though this was not something that could be used, that was supposed to be used inside FASTER, it was something that we could include in our design, and we have been able to do it so. So the pouch with the electronics is also modular. This can be turned off and back again if it is needed, along with this pouch. We have tried to make it as modular as we could. Now, this is a photo in order for you to understand a little bit about the size of the solution. I told you that this was something that was specifically asked from us in order to be delivered something that would be as small as possible and as unobtrusive as possible for the animal. I think that if you have the wearable there, you can have also a look with the final application development. And here is a small video showing you the design of the wearable. Just in case you are not able to see the video, see the wearable, I can show you the video. I don't know if you can see the video. This is the pocket with electronics. This is how we can take it out and then get back. We have been using velcros in order to deliver this safety recommendations, since they can be turned off if the animal gets tangled, as was without having this problem that we have been facing with the magnets. Now, moving on, a little bit of discussion about the communication capabilities of the wearable. Well, the wearable is able to be using Wi-Fi to deliver the messages received, the results from the process of the algorithm, because all the algorithms runs on the wearable, and they can deliver information regarding the process and for the location of the animal using the Wi-Fi connection. So if there is a Wi-Fi connection, whether that the wearable can connect to, the wearable will be using this Wi-Fi connection. Now, on top of this, since of course we understand that Wi-Fi connection might not be there each time, we have been developing an add-on to the animal wearable, which is the use of we call it a base station. Well, base station is a communication extender, let's say. It's a device, I will be showing you photos of this later on, that communicates using RF signals with the wearable. And when the wearable is not connected through Wi-Fi, the wearable can communicate through RF to the base station, and the base station then has a pocket Wi-Fi on top of it in order to be able to deliver through 4G the data to the faster cloud. Therefore, the communication can be extended, and also not only can be extended, but also can be delivered in locations where Wi-Fi is not available, since the base station uses 4G in order to deliver the incoming messages from the wearable to the faster cloud. So the wearable has two communication paths. One is direct when Wi-Fi is available, and another one uses RF communication through an intermediate, which is the base station, which is then able to deliver the message on the faster cloud. So this is the base station. You can see the device here, and here is the same device with the pocket Wi-Fi that is delivered to us by Cosmote, which is one of the partners also of the project. Okay, so we have the RF module here, which is able to connect with the RF module that is on the wearable and gets the information there, and then by creating a local Wi-Fi network can deliver this information to the pocket Wi-Fi, which is able to, using cellular communication, deliver the data to the faster cloud. Now, as I told you, one of the main focuses of our work here in the animal wearable was the training of the AI algorithms in order to deliver bark detection and activity recognition. In order to do this, we had to get some data from the dogs, and this is a small video that was prepared for the publication that was delivered. I think it was on January, and I will be showing you now the video. Hopefully you can see it. Here you can see the first responder that places the wearable on the dog. Here you can see the activity of the dog, and here whether it barks or not. Here now the dog is not barking, and now the dog is starting to search. It's not standing. When it stops a little bit, standing is advancing. So you can see here how these measurements are taken using the video. Now let me jump through the video in order to go to the location where the animal is actually barking for when the victim is found, and you can see here also the bark detection algorithm that has been displayed. And here is the fact that the animal finds the victim and barks, so the barking is advanced. So this is the result of the scientific results regarding the AI on the wearable. And I was also be talking with you about the smartphone application that we have prepared in addition to what will be displayed on the corporate pickup. So this smartphone application displays the animal location, the activity of the animal, whether it's standing or sitting, and the behavior, whether it's barking or not. Here is a small demo of the smartphone application. Keeping in mind that the actual data collection was taking place in Spain, this is the demo that was produced using the data coming from the animal wearable training data collection from Spain. So you can see the animal is not barking, now it's moving. It was standing, now it's moving. This is the map, and here is the wearable, the ID of the wearable, the activity recognition, and of course the movement. As it moves, keeps on moving, and now the dog is barking, but it's still moving. And we're waiting. When the dog sits and is barking, then we have the notification that the victim is found. Okay, this is something that could be that the handler of the dog is able to see on the smartphone on his hand. And this is, let me say once more, this is additional to the information that is delivered to the Faster cloud. Now, regarding the pilot participation for Faster, but the animal wearable has been mainly participating in Spain because the K9 unit that takes place in Faster is located there. And of course, we are in close collaboration with them, along with the data collection for the piloting of the tool. And it also will be displayed next week in Finland. We have been demonstrating you. Also, we have shipped to you and wearables so you can see it there. And of course, there is a final pilot to Spain. Fabio was mentioning earlier on next month for the final demonstration of the tool. Now, here are some features about the animal, about the web tool, the animal wearable tool that are delivered. I will not be repeating information that has been already said. I will just say that there is also the possibility to deliver a pre-recorded message to the victim when the algorithm understands that there is a victim found. Then the pre-recorded message can be played on to the victim, for example, saying that help is coming, stay calm. Okay. Also, there is also the use of the camera can be also taken advantage of, not for real-time streaming, but only for photos for Faster. Okay, so more or less this is the presentation about the wearable. I don't know if you want me to stop here and ask for questions, or should I move on with the rest of the tools, and then I will give you the chance to ask me about each one of them. Maybe it's better if I stop after each tool to ask for questions. It's okay with you.
Dimitris, I have one question.
Yes.
Operating your prototype you've sent to us, we saw and we felt that a part of that electronic device is giving some warmth when operating. It can be warmer even, and I don't know if the dog will be comfortable with that.
Yes, we are aware of this.
That's one remark. Thank you.
The material of the wearable is such that is quite resistant to high temperature. This is something that you have also asked from us, and we have been searching about the material. The wearable gets, I know what you mean, and the only solution that could be done for Faster was to find a material that could be resistant to heat. Okay?
Okay, maybe I will show you using my camera, okay?
No, I understand what you mean. I know what you mean. You mean the temperature of the electronics gets very high.
Yeah.
Yeah, I know. I know. But the pocket of the electronics is on the wearable. And
okay, thank you. Has anyone had some questions? No. So everything was clear, and you can jump to next topic. So smart textiles. We have something for the animals, now for some people.
I'm sorry, I didn't hear you very well. Can you please repeat?
Yes, you can proceed.
Okay, thank you. So, we have been talking about the tool for the animals. Now, the other two tools that I will be describing all are for the first responders, the persons. And moving on with the Smart Textiles framework. Well, the Smart Textiles framework is a prototype solution, and it consists of 3 submodules. The first submodule is the submodule that is used for biometrics, to monitor the biometrics of the first responder. It is placed inside the uniform of the first responder in order to be able to monitor its biometrics. There is also the environmental submodule that is being located on the outside of the uniform of the first responder, and it's used in order to monitor the environmentals, temperature, humidity, and carbon monoxide levels. And both these submodules collect data that are sent to a custom smartphone application that we have been developing for Faster. And the data there can be visualized and also processed. This application is able to generate alerts based on the data that has been received for each sensor. These alerts are generated on the smartphone, and they can be propagated to the Faster cloud architecture. You should know that this propagation of the alerts is completely GDPR compliant. We have been using a color code, as you can see here, the code with the 5 colors, and that describe the intensity of each of these thresholds. And this solution offers GDPR compliance by producing alerts that express the severity by a color and not by the real measurement. The measurements are on the phone, are not saved, but they are being processed in real time in order to deliver this color code generation of alerts. Now, this is the biometrics belt. This is the belt that we'll be using. This is the T-shirt that we have selected. In fact, we have sewn a place there in order for the belt to be worn from the each side. So someone should only wear the T-shirt and the belt will already be placed in the place. These are the sensors that we've been using from the belt. We have the heart rate, the breath rate, the estimated core temperature, and the acceleration through force. And in combination with the T-shirt, this is the biometric module of the Smart Textiles framework. At the same time, this is the environmental module. This is a small case that includes sensors for temperature, humidity, and carbon monoxide. This is the casing that can be worn on the shoulder of the first responder on the outside of its uniform. These are more photos about how to charge the device, and the actual functionality is very easy. It can be turned on or off using a switch on the back of the case, on the top of the case, as you can see here. This is the second submodule, the environmental submodule. Now, both these modules generate measurements, track on real time the measurements, and send them to the smartphone application. As you can see here, this is the two different tabs of the biometric of the mobile application. For the biometrics here, see, just to note that this is the first tab before the connection with the belt is achieved. This is connected. You can see they have measurements, and also you can also see here each measurement is mapped to a certain color. Okay, so the mobile application can also display the color where each measurement belongs to, and keep in mind that these data that are pushed away from the smartphone to the faster cloud, the alerts that are generated use only these color codes in order to spread information about the measurement for each sensor. And this is the tab for environmental submodule information. Okay, now I have a small demo of the Smart Exercise Framework application. You can see in real time the collection of data from the tools. Here is also the tab where the alerts that have been generated is gathered in order for someone to keep history of what has been delivered. This is how the information coming from the Smart Exercise Framework can be seen on COP or GCOP. You can see here we have the sensor and we have the color that represents the measurement that is being delivered. You can select the first responder, and then you can see the information for each one of them here. Now, regarding the participation for the pilots, Smart Exercise Framework has been part of several pilots so far, including Finland. In fact, next week we'll also be there. In Greece, where it has been tested both indoors and outdoors, and we have also been able to demonstrate it and pilot its performance with the cooperation of Respond A and other Horizon 2020 program, and of course in France and in Italy. Now, these are the basic features of this tool. We have biometrics environmental data collection, the detachability. You can see that the shoulder is also using the velcros in order to be able to detach it, and the generation of alerts that are GDPR compliant and with the use of the color codes. I think that's all for the Smart Exercise Framework. I'm open to questions if you have, please. So, no questions?
If you are ready, just wait. If you are ready to continue, the floor is yours, as it was in the last minutes.
Okay, thank you. So I will be presenting Rescue, the final tool that I'm here to present. The Rescue stands for Resilient Communication Equipment. It is a resilient communication device, a small low-cost device that operates when the network infrastructure is damaged. you can use the device in order to generate and spread short text messages, encrypted short text messages, using Bluetooth Low Energy. And these messages can be propagated locally around the device, and everyone with having installed the smartphone application that we have prepared to can decrypt these messages and read them. Also, in Faster, we have been using several rescue nodes in order to create a mesh network and extend the coverage of the succeeded coverage. Okay, so what are the advantages of such a solution? The advantages are that it can operate independently of the communication infrastructure status, and given the fact that it uses Bluetooth in order to send the messages, the number of recipients of the messages can be unlimited. Each one that has a smartphone with the application and is in the area, since this is something that has been propagated, can capture and read the message. And of course, this is also a dynamic solution, since by placing more nodes, we can extend the coverage of the succeeded coverage. Now, in Faster, there are two ways that we can use this tool. The first is by having pre-installed the device in certain areas that we know that can combine their messages and create this mesh network, and trigger the delivery of the messages when the time comes. This is something that is tested in Finland, and also in Spain there is a dynamic generation of the network, where each first responder can carry one device and can place it in places where it needs to, in order to be sure that this message can be spread out in the area. Of course, these are just some ways where Faster uses the rescue boxes, but of course they can also be used for other scenarios apart from those that are tested for Faster. Now, a little bit under the hood information. This is the fact that we have the text message which is split in pieces, and the chunks are being spread out, and each of the nodes that is located in the area searches for these chunks, reunites the message, and then be able to reproduce it. Okay, this is the mobile application for rescue. This screen shows you how you can select the group of recipients. I've told you that we needed the application in order to deliver encrypted messages, and there is a public channel where everyone that uses the smartphone application is already subscribed to, but there can also be separate channels, and the recipients for each channel would share the same key. Therefore, this is how you can select the part of the recipients that you need to deliver the data, meaning that if the first responder wants to produce a message that can be seen only by them, they can do so by creating such a recipient group. This is how you can enter the encryption key, and if everyone uses the same encryption key in their smartphones, then they will be joining the same recipient group. Now, this is the screen that shows how the data are displayed. They get the chunks, and each chunk that is received is displayed there until all the message is able to appear. This is the rescue. This box has a LED that indicates the status, and there's also a power switch here. Now more details about the smartphone application. This is the UI for the generation of messages, meaning that the smartphone application is not only able to be used to receive a message, but also it can be used to generate a message. Okay, and this is the screen for the special rescue box that is able to be used in order to trigger the spreading of the broadcasting of the message from far away. You can use RF. There is a special box that uses RF communication, and you can. This special box has pre-installed messages, and by using this application, you can select from far away, from RF distance, you can select which one of the pre-installed messages you need to broadcast. So the selection will take place from the smartphone application. This selection would reach this special rescue box, and then this box will start to broadcast the selected message. Other rescue boxes in the area would receive this message and would also reproduce it, broadcast it again further away. Now, this is a small demo for the use of rescue. I will be explaining you a little bit the scenario. Here is the rescue. We have been testing rescue in the university premises. This is a bridge outside the university, and there is one node that has a message broadcast. We started from this node, then we have two more nodes on the inside of the university, and there is finally one final node, a smartphone, that is able to receive the message here. Overall, this is more than 100 meters distance from one node to the last one. And of course, you can see that on the inside, you need more nodes in order to be able to increase the coverage and achieve the needed performance. Here's how we generate the message. Here we are outside. We start broadcasting of the message. And you can see here, this is where the next node is on the window of the building. It's already turned on. You can see we are now here. And when this node receives the whole message, propagated, here this is another node. And here on the back, this is the second node, and the final node here is the smartphone. You can also see the screen and also the screen capture here that starts to receive the chunks of the message. And you can see first the second chunk was being received, and afterwards the first one, and the application was able to reproduce the whole message. Here is another demo that showcases the broadcasting, the relay function of the network. Here we have generated a message to one of the rescue boxes, and we can see here that having the mobile application and the mobile phone near to the only one active rescue box is able to receive the message and display it on the screen. Then we will power on the next rescue device. We will stop the smartphone application. Now the message has been broadcasted from the first rescue device to the second one, and now the second one is the only active device. And we can see that the second one has been able to receive the whole message and now broadcast the whole message by starting again the smartphone application from scratch and receiving now from the only active node, which is the one that has been able to receive the message. And we repeat the same process using a third node. Each time only one node is active when the smartphone is been receiving, to showcase that this hop by hop communication has been achieved. Okay. Now, a little bit about the testing of the rescue device and pilots. In general, rescue has been tested both outdoors and indoors. Of course, indoors needs to use more nodes in order to receive the performance that's needed. On outdoors, we have been able to measure that the message can achieve 100-meter distance in line of sight situation from one node. So you can understand that the relay networks that can be built in the outside can have increased distance with fewer nodes, while as on the inside, on indoors, more nodes are needed, depending also on the material of the walls. We have tested fire rescue in Fitness, Greece, where there was an old building, and when there was a concrete, we had to produce more nodes in order to go around the obstacles. Okay, so here are some a summary of the features of the tool. We have I have been talking about it, so I will not be wasting you more time on this. This is more like a summary for what we have been discussing so far. Now, this concludes my presentation about these three tools and rescue. Please, are there any questions regarding the other one?
Thank you, Dimitris. It was one question, and colleague asked if we need internet connection for rescue, and I answered that we need that connection.
No internet. Rescue operates locally through BLE, and it has no limitation about the network status. It creates an ad hoc network by itself, and you do not need anything, just rescue nodes and the smartphone to have the pre-installed application to receive and read the messages. You do not need internet for rescue.
So it works using GSM net?
No. Using it just uses Bluetooth to send message locally. You do not send these messages online. You send these messages in the area. The idea is to create an ad hoc network in the area where, when, for example, you are a first responder, you have to operate somewhere where there is no communication. You can use these nodes, for example, to provide directions for any civilian that is in the area and can have the smartphone application installed. You do not need GSM, you do not need internet, you just need to spread the nodes in the area and use the phone to deliver, even in flight mode. Let's say, you just having the Bluetooth active, you can receive the messages.
Okay, thank you.
You're welcome.
Dimitris, thank you very much for your support and readiness and giving those presentations. And I think maybe some of my colleagues will have some questions in the future, so maybe they can contact you and address some questions to you with an emails. Okay, an email?
Yes, of course, you can share my email. I will be very glad to
I can't
answer
hear
any
you.
questions. Sorry?
Can you repeat?
Yes, of course, you can share my email. I will be very glad to answer any questions or discuss about possible ways to use the tools that have been presented so far.
Okay, so thank you very much, and I would like to join us, Professor Niedzielski and Mr. Tomasz Motyl for the next presentation on the Sarua V project.
Raz, dwa. Raz. Okay, so can I continue? Okay, so I'm continuing the presentation on the SAR UAV system. The next slide is on what the system does. So from the beginning of the software, you can follow two paths, two roads. The first is towards the right, which is the mobility model, which estimates where the person can walk into within a given time frame. And this information can be used for spatial, planning searches using any method, including a planning UAV mission. So you can, if you do not use UAV, you can simply use it for planning searches with dogs, vehicle patrols, and so on and so forth. And if you have a UAV, of course, you can use the mobility model to plan the mission. And of course, you can use it to plan the mission, but from start, you can skip mobility model and you can use detection itself without modeling mobility. So you can carry out the photogrammetric flight, which is here. Then you can produce the set of nadir JPEG images as we did yesterday. And having acquired images, having taken photographs, which should be nadir, so the camera is looking down, you upload images to the laptop on which the system is installed, and you run the person detection algorithm, and the output is the automatic detection of a person. And now a very short information on how the mobility model looks. You see here the red to yellow scale polygons, which inform the planist where the person can reach, can walk into within half an hour, 1 hour, 1.5 hour, 2 hours. Of course, the number of hours is to be set by the user. But as you see, these polygons are not concentrated, so they do not follow the circles. That's why this is definitely more robust information on how the person walks, because this simulates the real walking of a person on a true terrain. So given the slope and given the land cover, including forests, water bodies, reservoirs, fences, rocks, and so on and so forth. So this is information which is pre-flight information to be used by a planist to plan a flight or to plan any mission in a field. And then we carry out a photogrammetric flight, which is something which you all know. So it's a systematic way of capturing images, like in photogrammetry, identically as photogrammetric approach advises. So the camera is looking down, nadir or near nadir. Near nadir means if the wind moves the camera slightly, such an image is still acceptable. But oblique imagery is not advised. Then side overlap 60–70%. Side overlap. So when you compare black to blue rectangles, the overlap is 60–70%. And the front overlap or frontal overlap 80%, which is overlap in a row in a given UAV path, one image after another. And the ground sampling distance, we say about ground sampling distance rather than the altitude, because it's a function of the camera itself and the altitude. So we recommend 1 to 2.5 centimeters per pixel, with recommended 1.3, 1.5, which is very easily achievable using many off-shelf drones. So it's very easy to be achieved by multiple UAVs available on the market. And the platform velocity should be high, so it doesn't mean it will not work with images taken at the speed of 3.5 meters per second, but 2.5 to 3 prevents, this interval prevents the bad quality of imagery because of too high speed of a drone. Then frontal and side overlap. I mentioned about it 1 minute back, but now in detail, and I think this image, this slide, explains why it's important. So when you consider frontal overlap, orange or red rectangles, n+1, n+2, so images taken one after another in a row, you see the gentleman visible close to the tree, wearing some blue t-shirt, and then n+1, we see only the leg of this gentleman, and n+2, it's the same place, exactly the same place, but the tree is covering our gentleman standing there, and we don't see in the visual light this person. That's why we apply photogrammetric approach. We do not do any photogrammetry, not at all. So we are not building an orthophoto image, not at all. But we take use of a photogrammetric approach to prevent such a situation as you see in n+2 image, because if we have only this one, we skip n and n+2, and we don't see any information on the lost person. Identically with side overlap, so you see here the blue-violet rectangles in first, second, and third row of our UAV mission, photogrammetric mission, and you see the lady sitting here close to the wall. Image K, the lady is visible. Image K+1, you see the drone is traveling towards a different direction in the photogrammetric manner. You see only legs, still detectable by a detector. K+14, so the image in the third row, exactly the same place, this lady is not visible in the visible light. That's why we complicate this issue. So we load so many images because we do not want to lose the information on the lost person, and we simply want to have every single place photographed from different locations. And then automated detection of people, which is our key thing. So having taken imagery, we run the application, and the output is a set of pins put on the map, and every pin is associated with the coordinate in a right-hand side panel, which is called the verification panel, and to every coordinate you have associated or listed below each coordinate. You see the listed images, the names of images, in which a person or the object resembling a person has been detected. And because of photogrammetry, to every location you can have a multiple different images, different names and images combined or associated with them because of the photogrammetry itself applied to capture images. And skills of the software, very quickly, the ring model and the mobility model. The ring model is done only partially because we visualize rings, which are commonly used by rescuers, but mobility model is fully modeled given the point last seen, so given the place where the lost person was recently was last seen. And computation are carried out in SAR UAV. But the rest from this point of planning tool, of course, is something simple. Concerns detection of persons during the day, of course, because we focus on RGB. Detection of persons at night, no, because we use RGB. But our partners took some RGB images lit by UAV-mounted torch, and the detection was successful. So this can be kind of a in-field solution to use our software at night. Detection of persons in open terrain, of course, it is dedicated for open terrain, and urban areas, yes and no. So it will work normally, but it will produce extra false positive because of variety of terrain. Especially people have various things in their backyards, and similar to persons, for example, some rails and whatever. And of course, this can produce some kind of extra false positive sets. Yeah, exactly. And detection of persons in forest, no and yes. If you have a vegetation period, it will not work because of RGB signal. If a person is hidden below the well-developed tree in the summer, it won't be the person won't be detected. But outside, when trees are with no leaves outside the vegetation period, of course the detection is doable, and we had quite a lot of, I'll show you in a moment, quite a lot of exercises which confirm it works when leaves are not in trees. And detection of hidden persons in buildings, under rubble, so it will not work because of the RGB signal being processed. And persons in water, yes, we have a dedicated water detector, but of course on the water or close to the water. We do not focus on some deep water detection, which is definitely a sonar or green lidar things to penetrate deep in the water. And detection on snow is not a problem for us. We do it. Very shortly, how good is our detector in terms of true positives? So 10 flights, photogrammetric flights, carried out in different terrain and different land cover, as you see here in this on this slide. And the performance varies between 86% to 100%. Overall, 70 different people were sought, and 67 were detected. It means that, of course, it's a high probability detection, but still it's a probabilistic approach. So we understand, and we want our users to understand that the system, even with so high performance, can fail because 3 people have not been detected. And just very shortly, because I do not want to go too deeply into individual cases, I'll show you our tests with pluses, meaning successful detection, and minuses here, showing cases where the detector was not good enough to detect persons. So you see quite easy things like the rider here or the rescuer here, and something a little bit more difficult here or very difficult here, and easy here, some firefighters here, quite difficult here, very difficult here, but here difficult and not found. So I won't be talking about every individual case, but as you see among these, you can see, for example, the case here in the bottom line. The lady is standing here, very, very difficult to be detected visually, but the system managed to do it. But the child, the school-age child here, sitting on the tree, was not detected. So it's definitely very successful with our understanding. It can fail in some cases. And now I'll move to the second part of my presentation, which will be on the proper topic on today's talk, which is the first successful rescue of a person using the SAR UAV system. And I will read this sentence to be precise. We report on the real search and rescue action in Beskid Niski, this is in southeastern Poland, conducted on 28th and 29th of June 2021, last year, during which Bieszczady Mountain Rescue Service, Grupa Bieszczadzka GOP, employed the system. This Grupa Bieszczadzka is one of our first users, employed the system on the second day, so it was a really serious thing, serious story, of searches for a missing 65-year-old man. And this, a very short image here, shows you the cover of a paper, first successful rescue of a lost person in Beskid Niski. So we wrote a research paper on this because, to our best knowledge, this is the first in the world successful rescue using automated searches. Of course, there were many rescues, successful rescues, using visual analysis carried out by the analyst, but this is the fully automated detection. And very shortly, I'm very happy to describe you how the situation looked on the 28th and the 29th of June 2021. So the man left his house in the afternoon, about 3 o'clock, and about just before midnight, the man was reported missing by the family. And of course, the rescuers very quickly reached this place because GOP has its base in Dukla, very close to the village where the person was reported missing. And they started very serious activities together with police and with some volunteers. So quite a lot of people were there, and used different solutions, search and rescue methods like vehicle patrols, dogs, motorized patrols, walking patrols, and so on and so forth. But at some point at night, they decided to call for the UAV team from Sanok. They arrived and they launched thermovision. So they were looking for this gentleman using thermovision, and it wasn't successful. So the searches were suspended. They gathered new resources and then launched the searches again about 12 o'clock. And then about 1:50, they launched the SAR UAV software, and they started to process imagery. It wasn't a continuous process like we recommended yesterday. So they collected imagery, and then they processed after a few hours. But they processed. And 1821, the software detected a missing man, provided the coordinates, and within, I would say, half an hour, the gentleman was reached by the rescuers, and very shortly transported to the medical emergency service, and looked in the field like this. So this map presents you 5 RGB flights, so it doesn't show the thermal vision flight, which wasn't successful. So the flight number 1, again flight number 2, flight number 3, number 4, and number 5. And this location, the red dot, is a find location. So within the flight number 3, the gentleman has been detected. This slide is very important because people very often ask how many false positives you have. Yesterday you saw some pins with false positives, and we want to have this false positives because we do not want to miss individuals. And you see here, for RGB flight number 2, 4 hits, not successful. RGB number 3, 32 hits, among which 3 hits were into the lost person. Number 4, 22 hits, no person in the RGB 5, flight number RGB 5, 23 hits, not successful. But within flight number 3, it was successful. 3 of 32 hits were into the man who was sought. And as you see here, the snapshot from the application, from the software, this pin here, it's the image after the processing of the analyst. So this pin is green, confirmed, and the gentleman lying here. The gentleman was quite seriously ill and was not walking but crawling rather, and it was very important to find him quickly because the Alzheimer's disease as well he suffered from, and we managed to help. The grass was very high, and just before the rescuers were walking close to this place, we had some GPS paths, but because of very high grass, the gentleman was not detected, and maybe it was crawling, walking very slowly, misleading the troops. And instead of summary, as you see here, very successful story. This is the moment the gentleman is transported to the ambulance, and as it was the first automatic detection, the Polish television, main Polish television and Polsat News talked about it quite widely, and we're quite proud of it. So thank you very much for the attention, and I'm very happy to answer any question that arises. Thank you. Thank you. Thank you very much.
Thanks.
So you mentioned the specifications of how the images should be taken, the pixels per centimeter. But what does it mean? What's the typical altitude that your drone flies?
If you fly with 20 megapixel, which is very cheap off-the-shelf resolution of the camera, it's about 50, 60 meter, and you can reach it easily. It's recommended, about 1.3, 1.5. If you fly about 70 meters, it's still fine. So if you work with 42 megapixels, which is becoming very common now, you can fly higher and to get it quite easily. This recommendation is not a problem for our users at all. But yeah. Yes and no, because if you have a higher flight and a larger swath, larger image, the site overlap moves you farther. So the distance between consecutive paths is larger. So it's not like the same distance because that time will be a high, very high overlap. No, the overlap is 60%. So if you fly higher, the next trajectory, so the next path is farther, so it's not that bad. Of course, it can be, in frontal overlap, it's the same story. So it introduces the same overlap, but the images are taken more rarely, so not so quickly, and the paths are spread, so located farther from each other than in the lower flight. So it's sorted out. Yeah, it's a great question, but our approach is for many reasons, maybe legal reasons as well. So we do not produce the recommended flight path on purpose. We do not want to do it. So we simply leave this issue, flying issue, to the operator, to the user. If the user has 3 drones and manages it, no problem. They can simply put one into the software, one data set, then the second data set, and so on and so forth. But we do not produce within the software the recommended flight path for even for one drone. So we don't do it for multiple drones as well. But it's doable. But this is on the side, as I said, of the operator's side. If it's doable, the processing can be one after another. Thank you. Some questions? Yeah. Yeah. The person was found in the flight number 3, RGB free. So I do not count thermovision. It wasn't successful, so they decided during the day, holiday, to use RGB, which was definitely a good choice. So the flight number 3, and unfortunately, they did not process it after the flight. So that flight was carried out about, I don't know, maybe I've got it on the slide. No, I don't have a specific time. In paper, of course, it's in. It's about 1 or 2 o'clock. But the processing has been started 3 hours later because they were flying, and not processing. Normally, if they followed the proper recommendation, the processing should have been done exactly after the processing. So the success probably might be after 2 o'clock. But it happened 4 hours later, not because the software needed 4 hours. It needed, you see here, very important. Maybe this answers your question. Very importantly, look at this. Flight number 3, 32 hits, 3 hits were successful, and the overall time of processing, including the planist or analyst doing the job, 5 minutes, 48 seconds. So the processing time was copying images, 48 seconds, duration of the computations 1 minute 50 seconds, duration of analyst work 2 minutes. So as Tomek did yesterday, yes or no, false hit, true, false positive, true positive, and then duration of additional activities, which I mean creating new mission folder, uploading images, some kind of technical thing with the issue of not being connected online. So you have land and put. And this should have been done about 2 o'clock, but it happened later because they started UAV processing definitely later, which is shown here in the timeline. 150 they launched then software, but then they waited. So the imagery was not processed one set after another. At some time they decided to process, and they found. I don't know whether this answers your question, but probably. Thank you. There was. Yeah, very good question. This was done by the planist. And in our software, there is a mobility model which advises where the person might have gone from the point last seen. But in this mission, it wasn't used. So the rescuers decided to allocate these resources somewhere. Maybe I will be more precise. This is a point last seen here, last known point. So the gentleman was seen in the field somewhere. The neighbor was noticed him and was even having a chat with him. And they decided to fly here twice. And then from the IPP initial planning point, they decided to carry out this flight, and then these two. The planist made the decision, and I was not there. So maybe Tomek knows something more about it, but probably Tomek, do you know? No. So the planist was making decisions where to allocate resources. Something very important, they allocated different resources in this area as well. So dogs, motorized patrols, and walking patrols. So everything was carried out in here without success, and then the system helped. Yeah. And definitely, because this person was not very mobile, so was walking very slow, crawling when sitting or lying. So he wasn't very mobile. But very importantly, these images were taken at about 1, 2 o'clock. We can check it to be precise. But imagery was processed later, even though the coordinate estimated by the system was true, and they went there, and the gentleman was within the very close area from the coordinate estimated by the system. Even the time passed. Yeah, rural area is the best the best area to be scanned by the SAR UAV software. Forest is not the best in the vegetation period. If a person is hidden under the tree and when leaves are well developed, the detection won't be successful. But after the vegetation period, it's definitely quite successful. So the condition, very important condition, as far as the person is visible, or part of the person is visible, because we put the probability quite low. If we see only legs, they should be detected. The detection should work. Mm-hmm. No. I don't know whether it failed. I can guess, because the gentleman was quite mobile, as you say. Last known point, and you see the scale here, so it was about 1 kilometer between the last known point and the find location, and maybe at the time of scanning, the gentleman was in the forest, was not visible by the thermal vision. Maybe because of calibration of the thermal camera as well. There may be many issues. I don't know why it wasn't successful. Thermal vision, I do not work in thermal vision, but I have many consultations with rescuers, and many of them say it's a great tool, but it doesn't solve all problems. So, for example, hot day, summer, during the day it was over 27 degrees, and that time of the period of the year, definitely it's not the best period to use the thermal vision. Maybe that was the case as well, because the night was quite warm as well. I don't remember, but over 10 degrees. So it's still 10 degrees. It's quite a lot. So the gentleman was wearing 2 t-shirts and the trousers and boots. Maybe it was the difference between temperature was not as high to be detected. Maybe this was on the top of the, for example, being in the forest. We don't know it. Maybe that's why it failed. This is my guess. Probably might happen. So thank you very much for inviting me and for so many questions, which is always very inspiring. Thank you. Thank you.
So I think that's all for today's meeting. I distributed within the chat the links to questionnaires. If someone of the participants would like to answer some questions for our project, we will be more than happy. And also, I would like to ask any law enforcement participants to answer the questions from our survey questionnaire. First of all, because we do need your support, your remarks, and also any of your comments as a part of the project to have an impression what the other colleagues from different services are thinking and what ideas probably they have on our technologies and tools, but also any other ideas which can be a future part of the project or similar projects. Thank you very much for the participation.
Thomas,
and if someone would like to know more about the project, me and Thomas, we would like to encourage you to contact us, to take a look on the website of the FASTER project, and also maybe if you are interested in very important project of Professor Niedzielski and Mr. Tomasz Motyl. So contact us. Thank you very much for being here and listening to the presenters. Thank you, Kogias, Dimitris. Thank you, Nicola. Thank you,
can you hear me?
And all the participants. That's the end of the
George,
teleconference.
can you hear? George, can you hear? Hello? Hello? Hello, George? No, va più.
Fabio?
Hello, George, ma non mi sentiva nessuno?
Fabio, ti sento io. Mi senti?
Non capisco, loro non sentono. Volevo fare una foto.
Infatti.
Hello? Non aver l'audio chiuso.
Dico, io qualche foto durante la cosa l'ho fatta,
Hello? Saverio.
George? Can you hear me?